Welcome to Mathematics Alive, Algebra Lesson 31, Systems of Linear and Quadratic Equations. Let's start with example number 1. We have equation 1 and equation 2. Equation 1 is a linear equation. Equation 2 is a quadratic equation. And both are expressed as y in terms of x. So we equate the right sides of the equations because y is equal to y. And let's start with the algebraic solution. Equating the right sides of the equation, we have x squared plus 2x minus 3 is equal to 1 minus x. And then we will solve for x by setting the right side of the equation to 0. X squared plus 2x plus x minus 3 minus 1. So we have x squared plus 3x minus 4 equals 0. And we can factor this expression. We have x plus 4 and x minus 1 equals 0. So x is equal to negative 4 and x is equal to positive 1. And we will be solving for the values of y. So we can substitute these values to any of the two equations. But of course, it is easier to substitute it in equation 1. So at x is equal to negative 4, y is equal to 1 minus negative 4, and y is equal to positive 5. And at x is equal to 1, y is equal to 1 minus 1 or 0. And so our solution set to this system is a set of a pair of ordered pairs. So we have negative 4, 5, and 1, 0. Okay, this time we will do the graphical solution. We will graph these two equations starting with equation 1. So equation 1 is a linear equation. So we just get the x-intercept and the y-intercept. So for equation 1, we have x and y. When x is equal to 0, we have the y-intercept. So we simply cover this. This is 0. So y is equal to 1. And when y is equal to 0, we have 0 is equal to 1 minus x. So we just transfer x here. So x is equal to 1. So this is our x and y intercept for equation 1. And we can graph that right away. 0, 1. And 1, 0. And we have this graph. This time we will graph the second equation. We have to solve for the vertex of the equation. For our equation 2, the values of the vertex and neighboring points will be solved. So we have the vertex at x is equal to negative b over 2a. So we have b is equal to 2 and a is equal to 1. So this value is negative 2 over 2 times 1 or negative 1. Negative 1. So x is equal to negative 1, y is equal to negative 1 squared plus 2 times negative 1 minus 3. Y is equal to 1 minus 2 minus 3 is equal to negative 4. So we will locate our vertex, and we have negative 1 and negative 4. Here is the vertex. And we will draw our line of symmetry. At x is equal to negative 1. Then we will get the x-intercepts of the parabola. So get the x-intercepts of equation 2 at y equals 0. So we set y equals 0, equation 2. 0 equals x squared plus 2x minus 3. And then we solve, get the factors, x. So we have positive 3 and negative 1. So x is equal to negative 3, or x is equal to positive 1. So we have 2 points here when x is equal to negative 3 and x equal to 1. Both values have a y value of 0. And we can locate those points again. We have negative 3, 0. And 1, 0. 1, 0 is here already. So we can sketch the graph. Somehow, but we need additional points. Let's have points to the left of the line of symmetry. Like we can get the point at negative 2 and at negative 4. So at x equals negative 2, we have y equals negative 2 quantity squared plus 2 times negative 2 minus 3. So y is equal to 4 minus 4 minus 3, or negative 3. So at x is equal to negative 2, we have negative 3. And then at x is equal to negative 4, we have y equals negative 4 squared plus 2 times negative 4 minus 3. So this is 16 minus 8 minus 3. So we have 8 minus 3 is equal to 5. Y is equal to 5. Okay. So we only need the values of the x and y coordinates on the table, and all of these solutions we can do in a scratch paper. And then we can locate these points, negative 2, negative 3. It is here. And then negative 4, 5. Negative 4, 5 is here. And then we can reflect these points on the other side. So we have one point here and another point here. And we can sketch the graph. Okay, so we see that the points of intersection between the graph of the parabola and the graph of the line are as follows: 1, 0 and negative 4, 5, which corresponds to the solution set in our algebraic solution. We have 1, 0 and negative 4, 5. So we have just solved the system of linear and quadratic equation graphically. Example number 2, we have equation 1, a linear equation, and equation 2 is a quadratic equation. But equation 1 is not expressed as y is equal to an expression in terms of x. So we have to simplify this in the form y is equal to negative 3x minus 6. And then we have equation 2, y is equal to x squared minus 4x plus 3. So we will equate the y's and the right side of the equation. So let's start with x squared minus 4x plus 3 equals negative 3x minus 6. Then simplify this equation and solve for x. So we have x squared minus 4x plus 3x plus 3 plus 6 equals 0, and x squared minus x plus 9 equals 0. But this equation is not factorable, so we will use quadratic formula to solve for x. So we have x is equal to negative b, or negative of negative 1, plus or minus the square root of b squared, negative 1 squared, minus 4ac all over 2 times 1. And x is equal to 1 plus or minus the square root of 1 minus 36 over 2. And this will yield a negative expression. So our x is not real. We don't have a real solution for this, meaning the equation, the system of linear and quadratic equation has no solution. So we have 1 plus or minus the square root of negative 35 over 2. This will be imaginary. Therefore, the solution set is empty. But we can still graph the system. We have the graph of a line and the graph of a parabola. But we expect that these two graphs will not intersect each other. Now let us solve this system graphically. I have already prepared the table of values for equation 1 and equation 2. So for equation 1, we have the y-intercept at x equals 0 and x-intercept at y equals 0. 0, negative 6, negative 6, and negative 2, 0. So we will connect these 2 points. And then for equation 2, the vertex is at 2, negative 1, 2 and negative 1 here. And this graph is going upward because A is positive. And then we have 1, 0 and 3, 0. And let's put the line of symmetry. The line of symmetry is at x equals 2. Then we add another point, 0, 3, 0, 3, and 4, 3. So we can graph this. Be sure that there is a curve towards the vertex, and then connect the other points. And then you can name the points here. So we have here 3, 0, and 1, 0. And the other points are 4, 3, and 0, 3. Okay, and we clearly see that the two graphs do not intersect each other, and therefore the solution set is empty. Now let's have example number 3. We have equation 1, a linear equation, equation 2, a quadratic equation, but it is not in the form which is in the standard form. So we have to rewrite this one as y is equal to an expression in terms of x. So y is equal to x squared minus 4x plus 5. This is equation 2. And then we have equation 1, y is equal to negative 2x plus 4. And then we will equate the right sides of these two equations. So we'll start with this. We have x squared minus 4x plus 5 equals negative 2x plus 4. Then we will solve for x, and we have to set the right side to 0. X squared minus 4x plus 2x plus 5 minus 4 equals 0. So x squared minus 2x plus 1 equals 0. And factoring this expression, we have x plus or x minus 1 times x minus 1 equals 0. Or since we have the same factors, we have only one solution here. We have x minus 1 equals 0, or x is equal to 1. And solving for y, we have y is equal to, we will use equation 1. So y is equal to negative 2 times 1 plus 4. So 4 minus 2, y is equal to 2. And so our solution set is 1, 2. Okay, and then we'll go to the graphical solution. We have already the values of the x and y intercept for equation 1 and the values for equation 2. So we have 0, 4, 0, 4, and 2, 0. Okay, and then we have 2, 1, 2, 1. We will first graph the line. this is our equation 1. And then the vertex here is at 2, 1. And we have 1, 2, 1, 2, 3, 2, 0, 5, and 4, 5. Let's draw the line of symmetry. X equals 2. Then we will graph the parabola. We can see here that the parabola touches the line at only one point, and this is what we call the point of tangency. So this is our solution. And this is the point 1, 2. Now to master this skill in solving the simultaneous linear and quadratic equation in two variables, you have to practice. So do your homework. This is your take-home assignment. So please don't forget to like, share, and subscribe to this channel by clicking the button below. Thanks for watching and bye-bye.